I love these developer days here. Right? We really get into, not the why, but we get into the how and dive really in. And I get put on stage here to talk about emerging technologies and bring toys with me. And then there are all these guys in front of me. They bring like flight simulators and stuff. I'm like, what am I going to do now? So what I want to share with you is some of the trends that I'm seeing out there across Asia Pacific and of course also Australia here and New Zealand. And I want to have a look in terms of how does that affect us as developers? What do we want to look out for? Where do we want to shape ourselves up? And what are some of the cool projects and open source tools out there and the overall trends? Now, if we think about it, we all want to innovate. Every company wants to innovate. We as developers, we want to create innovative products, innovative solutions. Now, there's an important element around innovation, which is the ability to be able to experiment, the ability to say, I try something out, and maybe I fail with something, but I take some learning out of that, and then I'll improve. If we talk about cloud computing, it enables us to experiment, right? We have 90 over plus services, it's API calls away, we can use them on demand, there's a free tier to it, that's great, it allows us to experiment. But most importantly, technology is not necessarily the issue here. It's very much about, are we enabling ourselves in terms of our culture within ourselves and also within our company to allow ourselves to experiment, to fail, but if we fail, to learn from it and improve. And if I think about, how we are deploying software applications these days, it has changed a fair bit. Traditionally, we had physical hardware, we bought servers, we put them in a data center, right? And we put load balance in front, we deploy the code. We decide, okay, maybe how about we virtualize that? We use a hypervisor. How about some cloud computing? Great, on-demand EC2 instance sounds great. I load up an AMI, just need to deploy my code. And we said, okay, how about we continue that process and say, how about all the libraries, the dependencies that we have, or parts of the operating system, we package that all up into a container, we ship that container out, and off we go. And there's something very cool about containers, You can develop on your laptop, you put it in a container, you ship it to a server, and it just runs. Because as developer, we all had that problem where you shipped something, it broke somewhere on a production environment, and you get called in and you're like, but it worked on my laptop, Must be the infra guy. That excuse is gone. But we're moving further. We're moving further into the direction of saying, let's build event-driven architectures. Let's build architectures where we focus on building functions, building that functionality as events are happening, completely removing the focus on the underlying infrastructure that powers it. Now, you're all familiar, and we heard a lot about AWS Lambda and serverless earlier throughout the day. It allows us to really focus on our code. It allows us to focus on developing without thinking about servers, without thinking about things like scalability or auto-scaling groups. It allows us to also just pay for what we consume. That's great. But what does it mean for us as a developer? Well, we got to change a little bit about how we think on how we develop our code. We got to think in event-driven architectures. Write a piece of code that reacts only upon a certain event. Now, there's some frameworks out there that can help you. The serverless framework is, for example, one of them. There are a few others out there. We also have what we call the serverless application model, SAM. Now, it allows you to actually develop your function locally now, and that's one of the new releases we did, locally on your laptop. Try and test it out, and when you're good to go, you push it out into your cloud computing environment. We open source that part, and talking about open source, I think one thing that's really important for us as developer is to continue to think about the fact that openness helps adoption. Openness helps to create new products, new services that weren't available otherwise. I want to give you an example of that. Some of you might be familiar with a device called the Amazon Echo. Amazon Echo is a device that actually can be used to talk to the Alexa voice services. Now, with me, I also brought the smaller version of the Echo, which is the Echo Dot right here. Now, if you're not familiar with what this device is doing, it actually allows me to use a certain wake word. The default would be Alexa, and then I can ask it certain questions or ask it to turn on the lights or Wikipedia something up for me. And by the way, that wake word, Alexa, is the default. You can change it to something else. You can change it to, for example, computer. For the Star Trek fans between you, computer, tell me about something. Now, let's have a look at how that works. Alexa, say hello.
Hello.
Alexa, how are you today?
To be honest, it's been kind of a rough day. Just kidding. I'm great.
There we go. Alexa, where are you right now?
I'm here and my head is in the cloud.
Ah, her head is in the cloud. Now that's a good thing because it allows us as developers to integrate against these voice services. So we can extend the capability of the voice services. It's open for any developer to integrate against this voice service. For example, you can play music from Spotify to your voice service, to your Alexa here. It also allows me, for example, to call an Uber or to, for example, get a pizza from Domino's or order a coffee. Now, how do we build something like that? Well, it's called an Alexa skill. And with the Alexa skill, we can use our piece of code to actually get the input of the voice, extend its capability, maybe query any backend that we have, and then respond in a rendered voice through the Alexa voice services back to the Echo device or any device that is running the Alexa voice services. So I figured, okay, how about we have a quick look at that? How would I extend the capabilities of the Alexa voice services? Well, we have the Skills Kit and the Skills SDK that would allow me to actually tap onto another platform that is also open in that sense. Facebook, for example, has an API, a Graph API, which I can query using an API call. And if I now use AWS Lambda in the middle, I can actually ask Alexa to read something from my Facebook page, for example. Let's have a quick look at that, shall we? I'm just going to log into my laptop here, and I'll be switching over to my screen. Now, if you want to build that, the first thing that we need is obviously a Facebook account. And if we have a Facebook account, we want to create, for example, a Facebook page. I created one here. I called it the Webhook Demo. Now, if we create a Facebook page, we can also sign up to be a developer on Facebook. Signing up just means that you go to developers.facebook.com and start creating an application. Now, if you do that, you get API access to some of the graph within Facebook. So how would I create now an Alexa skill that reads something out? Well, I brought a little bit of piece of code with me. We have something called the Alexa skill SDK, and that comes with, for example, node code here that allows you to just take some part here, the Alexa skill required, implement it, and then you can create certain skills for Alexa that we can then publish out. So for example, here I could say, how about a skill that allows me to read out new Facebook posts? And now you're going to say, Ollie, what is this thing? That doesn't look like Facebook Graph API. Well, what I did is I implemented it with webhooks. So in Facebook, you can actually create an app, and you can create a webhook, which means every time you have a change on your Facebook page, that will call a certain URL. What is that URL? Could be a server. In this scenario, we chose API Gateway with an AWS Lambda function. And whenever I have a new post, I actually store it in my DynamoDB table. Oh, and guess what? In the Alexa skill, I'm actually reading out from that DynamoDB table the latest post that came true. All right, let's try this out. So if I go here to my page, and I'm going to write something here. First post that coming true. Hello, Melbourne. And if I post this, let's see who else is posting with me. I love the interaction with the audience here. Let's now talk to our skill. Let's make sure it came true. Alexa, ask LambdaBot about new Facebook posts.
Olivier Klein was writing, "Hello, Melbourne."
Awesome. Hello, Melbourne. Thanks. Let's go back to the slides. Now, I love that post. I love that post. You know why? Because you're actually predicting my next slide. Because I'm talking about openness here. I talk about the ability to actually extend the capability of the Alexa voice services here. Most importantly, the Alexa voice services are not limited to who is using it. Have you heard of Cortana? Cortana is Microsoft Voice Assistant. really well integrated with Office 365, for example, allows you to get to the calendar, etc. As of a few days ago, you can actually call the Cortana voice services through Alexa, and you can call the Alexa voice services through the Microsoft's Cortana voice assistant. What does that mean for us as developers? This is a great example of how we need to be open around what we develop, because if we are open, us as developers, we will create integrations, and these integrations will eventually drive our business, or more importantly, make it more convenient for our end customers or end users to use our application. Now, which brings me to the point of this device is a connected device. Perfect example of what we maybe refer to as an IoT device. We all have probably mobile phones in our pockets, and we definitely know about APIs. And all of that leads me to come to the conclusion that eventually, more and more devices, and eventually everything will be connected. Now, that's a good thing because it allows us to collect a lot of different data points, a lot of sensor information, wearable information, collect my voice or video material from cameras, and that allows me to then process some of that data in real time, to get insights in real time, to react upon it in real time. And that data might come from my devices, but it might come from another platform, from that open platform that we want to create. And as we are starting to collect more data, we can start building machine learning models around those data points that we're collecting. We can start making predictions. And we can go to a point where we use, for example, deep learning machine models to actually build artificial intelligence on top of the data that we're collecting from our or other people's platforms. And eventually, that will improve the way we interact with our computer systems. Now, the important thing for us as developers, as we build devices that we connect, we need to make sure that security is job zero. It's the #1 priority. You cannot sacrifice security. Now, a lot of our services will make your life easier. AWS IoT, for example, allows you to securely connect billions of devices using the proper encryption and authentication. Whenever you develop a device, though, you as a developer, I want you to make sure that whatever you build, when you connect it, make sure that you have security always in mind. Think also about the fact, if you connect to a certain backend that you're creating, or a service like AWS IoT, more and more devices will connect, but not only more and more devices that you control, there will be more integration with other people's devices, other people's platforms. There's entire ecosystems that are building themselves, where a hardware manufacturer might integrate into your platform. Which leads us again to that point of continuously having data points that are coming through. Lots of data that is flowing in. Now, I said earlier we want to orient ourselves to more function-based programming so we can benefit a lot from the serverless approach. Similarly, if we have data points flowing through in, let's say, for example, AWS IoT or a Kinesis stream, we want to build our application in an event-driven model. Very often we want to publish or subscribe to a stream. So us as developers, we want to think about the context of pub/sub. As we continue to build applications, let's build functions that only react upon incoming data that is relevant for that function. Subscribe to only what you require. Have a stream or have something like AWS IoT that allows you to react upon only what you need for that specific function or reroute it accordingly. Now, I said I brought some toys with me, so how about we try to understand that a little bit better when I say connecting device, connecting things, using things like AWS IoT, AWS Lambda function. What could we do? Well, with me, I brought obviously the Echo Dot. You've already seen the Echo Dot here. I also brought with me a little Raspberry Pi, and I also brought with me a Sphero robot. This is the SPRK Plus version, which is translucent, so you can see inside. There's another version which was very popular. It was called BB-8, which is the Star Wars version of this robot. And it's a toy robot. It's great. We can put it on the floor, and it will start rolling around, and we can control it via Bluetooth. So what could I do with it? So I figured, wouldn't it be fun if I connect this robot to AWS IoT so that I could use my cloud-based environment to actually control the robot? How do I go ahead with that? Well, that Raspberry Pi there has the Model 3 version, which comes with Bluetooth. Awesome. Now that Sphero has Bluetooth low energy, and I can talk to Raspberry Pi. Raspberry Pi connected to AWS IoT, and now I have the glue to actually control the robot. Let's have a look at that. Just switch over to my screen here. Perfect. So I'm already in the Raspberry Pi here, logged in via SSH. The first thing that I'm going to do is I'm going to start my drive program.
Hello.
Hello. How are you? Now we're sending messages back and forth to my cloud computing environment. Let's have a quick look on how that looks like. Well, what I can do is I can go to my AWS IoT service here, load the console up, and actually listen to some of the topics that I'm publishing. I'll actually run this in our Sydney region, so let's switch over to our Sydney region and listen to the Sphero/everything topic. And now let's make sure that I can show you both things here. And what I can now do is I can send messages back and forth to, for example, have different languages here.
안녕하세요.
I'm still working on the Australian, so I'm going back to English.
Hello.
Now, what I can do is obviously send roll commands to that robot. In that sense, I could go ahead and make the robot roll around, remotely controlling it with a bit more speed.
Ouch. Ouch. Ouch.
And around.
Ouch.
You wonder probably why it says ouch. And if you look at that JSON string, it actually has a sensor that impacts collision. So if we have the right kind of collision here, we can play an audio file. Now the next thing, why do I actually connect these things together? Well, first, because it's fun. But secondly, there's no audio jack here where I can plug in. How do I get these sound samples? Well, I actually have a MacBook here, comes with a sound card. Awesome, right? So that MacBook actually runs in the background here a certain activity, and you see that I run macaudio.js here, which just listens onto the topic, and whenever it gets certain things like this collision, it will play a sound file. Cool, right? So we now gave our robot a voice. What else can I do? Well, since I now have it connected to AWS IoT, I can also use, for example, the integration with the Alexa voice services to talk to the robot. Alexa, ask Sphero to perform a stunt.
Sphero performs a stunt now.
There we go. We see the message came through, action stunt, and the Sphero rolls around. Alexa, ask Sphero to change its color to green.
I changed Sphero's color to green.
Alexa, ask Sphero to change its color to blue.
I changed Sphero's color to blue.
And if you look closely at the JSON, we're actually updating the IoT thing shadow. The thing shadow will synchronize with the Raspberry Pi, gets the Delta update, and then just changes the color of the Sphero. Cool. So now we have a robot that talks to me. I have the ability to actually use my voice to control the robot. How about creating a virtual world? So what we're going to do next is we're going to use an engine called Amazon Lumberyard. And Amazon Lumberyard is a AAA grade game engine that allows me to create virtual worlds. Now, actually, just for the fun of it, I decided to run that Lumberyard out of an Amazon workspace. Now, if you're not familiar with Amazon Workspace, it actually is a service that allows me to run a virtual desktop in AWS and connect to it. Why do I do that? So I have GPU rendering here to render that Lumberyard here. Now, what you can see is Lumberyard is an IDE and both an engine that allows me to create game worlds. So I can go, for example, ahead and say, well, how about I want that rock here and make that one a little bit bigger. So it allows for visual editing. It also allows me to integrate into AWS and potentially then connect and glue things together. Now let's first try to play this game. So I'm having my mouse here, and I can now navigate this robot around, can jump, and you see that the Lumberyard engine also comes with a particle engine, so we can run the wonderful fireplaces like this or forests like this, and we'll see the sun rays coming through. I'm just going to reset my position back to the initial one. And since it's connected to AWS, I can connect it to AWS Lambda, and as such, I can connect it to the voice services, right? Alexa, ask Lumberyard to say hello.
Hipster says hello.
There you go. Our hipster says hello. Alexa, ask Lumberyard to make it snow.
We made it snow.
There we go. And now we can use our voice to actually control a virtual environment. Now, wouldn't it be cool if I can control a virtual environment and control the physical environment at the same time? So what I'm going to do now is I'm going to enable, at a certain frequency, X, Y, Z coordinates that I send to AWS IoT that my Raspberry Pi can pick up and make the robot roll around. Let's try it.
Lumberyard connected.
There we go. And if I now roll around in that virtual world, we'll see that the physical world will follow suit accordingly. And if you look at the back in my console, you see that they're continuously at a 1 second frequency, messages coming through. Let's have a quick look at that. And you see that it sends certain updates around the directions and the speed where we need to roll. All right, let's switch back to the slides. I'll bring my robot back into its home pod where it can charge up. Now, if you think about this demo, why do I do that? Well, because it's cool. That's why. But this demo, I obviously didn't build it with the idea in mind like, I'm going to build Lumberyard, I'm going to build this, I'm going to build that. No, I decided to buy a Sphero, and I was like, that's cool, and you can control it with your phone, and I figured, all right, let me tap onto the Bluetooth signal, and by the way, there's a great library out there, it's called Silent.js. It's a great SDK that helps you with robotics, and Sphero is, for example, one of the robots that is part of it. And then you start connecting things, and initially I just connected it to AWS IoT, played the sound samples, and then you build up. That's the experimentation that I'm talking about. That's the part where we can freely integrate and are open around what we're building. Now, if we take something like this, how does that actually apply into our business world, right? Are we going to make a fortune out of creating talking Sphero robots? Maybe. I don't know. Maybe I should try. But I would argue that probably we want to use what we've just learned in other contexts. What you see here is actually a video that is recorded from a Microsoft HoloLens. And that HoloLens is actually using a software from PTC. It's called PTC ThingWorks. And what it allows us to do, it allows us to look at a machine like this one and stream in real-time IoT sensor data. At the same time, if we need to perform a maintenance, it can also overlay a 3D animation. And since we loaded up the CAD files of that machinery here, it also knows what is in front and what is in the back, so it can overlay it in a 3D model, even though it might just be a 2D recording of a camera. And that would allow me to, in this scenario, for example, look at it and say, okay, here's the air filter, this is how you change it. Now you go ahead and you make that modification, and you will immediately see, because you're streaming in real-time sensor data, if your maintenance was accurate or correct, or if it didn't work, or if you should change something. So now we're creating applications where we can use augmented reality to assist or train people. And basically the idea of connecting things now suddenly starts to make sense, right? We now have a complete new solution that would otherwise not be possible. So connecting things is great. I want to connect everything, right? Now, there are some challenges that come with that. Some round-trip latency, intermittent connectivity, bandwidth can be expensive. I love it when I'm here in Australia. I spent last week, I was in Canberra, and I decided, okay, let me drive around a little bit. I rented a car, and I drove around out of ATC, New South Wales, all the way down to the coast, came back up, And at the end of it, I looked at Google Maps, and I put like dots where I drove around, and I zoomed out. It's like, all right, that was like 5 pixels right there. This country is huge. Now that brings me to the point, if you look at some of the industries like mining, sometimes you mine like all the way out there. No connectivity. While I was driving around, I took out my phone all the time. No service, no service, no service. Oh, a new little village. There we go. 4G, back no service, no service. All right? So if you think about now deploying an application that is in a place that is not urban, we don't have connectivity, or we have intermittent connectivity. All right, let's build up a satellite link all the way to the top. Cost me a fortune. Can't do that. So one of the things that we need to realize as developers, certain operations and logic needs to live in my cloud environment where that makes sense, and some of it might need to live at the edge. Earlier, we heard at a great session here how we can use, for example, AWS Greengrass to make that work. AWS Greengrass allows us to react quickly upon events locally on the device and also operate offline. And when I come back online, synchronize with my cloud environment and only synchronize the data that I feel is worth synchronizing. At the same time, it makes it also easy for us to receive over-the-air updates. Where does that leave us as developers? Well, we want to focus on developing in various ways. Now, this is not a clear line. This is not a clear segregation. I'm not saying you're the one or the other. But the way you want to think about it is, when you develop applications now in this new IoT world, think about, do you develop for an embedded system? Do you program the device with some local logic? You integrate with the hardware sensors. You integrate with the hardware actuators. And that's a certain skill. Some of these devices are highly constrained. Get a few kilobyte or a few megabyte maximum of memory space available to you. Good luck loading up a Java JVM in there, right? You go down to C, not even C++, down to C. So if we are in embedded development, that's important because some of the devices, we have many of them, right? So we keep them slim and small. Now, with Greengrass, we can locally react between those devices. Why? Because we have a core Greengrass somewhere that it talks to this device before it talks back to my cloud computing environment. At the same time, as I now collect that data, I can enrich it, I can build and process that data, I can build application in my AWS environment. I can build companion apps, I can create integrations, I could even integrate it with the voice services. But the reality is that a lot of the data that you will process, you will execute and process that initially locally on the edge. And you will only move back what is relevant. And that could be a consolidated amount of information that you're collecting. And later we're going to talk a little bit about how that also plays an extremely important role in the AI space and specifically the computer vision space. But bottom line, it is important for us to create integrations. But integrations also in the sense that we need to tap into ecosystems, which also means you should open and create your own ecosystems. Openness allows it for adoption, but open ecosystems also allow for broadly integrated solutions. What do I mean with that? What you see here is a generic Bluetooth OBD connector. If you're not familiar with OBD, it stands for onboard diagnostics, and it's a standard that was developed a fair bit ago, and pretty much vehicles kind of manufactured after 97 should only have a version of it, OBD or OBD2. What it initially was designed for, it allows you to read out certain informations or sensor information that you have within your vehicle, in the engine, etc. Why was it designed? Well, it allows a car mechanic, if you bring the car in the mechanic shop, he can take a cable, he can plug himself in, he can read out the information and see what's going on. What do I need to repair? Something's broken. Okay, here's the pressure of the oil temperature, what have you. I can read it all out now and understand it. Now, this connector here, which is a small little device like this, allows me to plug it in and then use Bluetooth to read out this information. So what can I do? I can create an application that could now read out the information of my car. Cool. Now I can see what's going on. We're all developers. We probably love that. Like, yeah, how much power do I have on here? Yeah, there you go. Awesome. Realistically, though, again, is that really creating a very useful application? Maybe. Well, how about we enrich it? So there are companies like Dash. The URL is dash.by, B-U-Y. They allow you to use such a generic Bluetooth connector, connect it to your OBD connector of the car, and then start analyzing the data of your car in real time and provide diagnostics in many different ways. The first one is they want to improve the fuel efficiency on how you're driving. They want to positively influence your driving behavior, and they do that by gamifying the experience by giving you a driving score. How does that work? Well, if you had a red traffic light, you have two options. You either way slowly roll over it, or you go fast and jam the brakes right when you're in front of it. That's probably not the most efficient score, that I can tell you. Now that's nice, so we gamify that experience. But what else can we do? If we can read out the onboard diagnostic system, we can read out certain sense information, which also allows us to read out information like, is an airbag triggered, or what's the collision, etc. If we get into a car accident, we can identify that this is a serious car accident, and we can immediately notify the emergency services, tell them where we are. How do we do that? Well, this finger GPS, right? There we go. Now we integrated something and we enriched data with another device to actually do this. But let's take that one step further. Another thing that Dash is doing, they obviously now have lots of people that start bringing in pieces of information, data, from vehicles that are driving around. Now it turns out that obviously we sometimes often drive vehicles that other people are driving too. So what we can do is we can now collect that data and build machine learning models on top of the data that we're collecting, so that we can identify, okay, for this vehicle, this type, that year that it was built, this is roughly the data on how it should look like on an everyday basis. If we find outliers, we can maybe identify a faulty piece in my engine or a faulty piece in my car. If that happens, I can actually start predicting if something like that happens based on the different sense information that I'm getting. That allows me to actually potentially predict a vehicle breakdown. If that happens, Dash will notify you. They will say, okay, this is likely to break down or already broke down. Here in the surrounding areas are car mechanics that you can immediately go to and you can have it fixed. And oh, by the way, this is how much it will cost you to have this piece repaired. That's pretty cool, right? That's a great customer experience. And if you think about it, when I talk about openness and ecosystems, Dash didn't build the car. Dash didn't come up with the OBD standard. Dash didn't even build the generic Bluetooth connector. They just built an app that makes use of that open ecosystem to actually deliver a solution. And they use machine learning models. And if you look at machine learning and data analytics in general, there's a continuous trend for us as developers that is happening, which is the decoupling of storage and compute. Traditionally, we take a data warehouse, right? We stuffed all our data in, we run our query against it, we run out of space, we make it bigger and bigger and bigger. And does that work? Yes. Are we going to be bankrupt tomorrow? Probably. So that's not a scalable solution. If we think about big data, all the social media, all the different data points that you want to collect, that can go up to the terabytes per day or more. So that's not a scalable solution. So what a lot of companies have decided is, could we decouple compute and storage? Use something like Amazon S3, store all of our data in there. Now S3 doesn't quite support us to run a query, but there are services that allow us to do that. Amazon Athena, Amazon Redshift Spectrum allows us to query data in S3 right where it lives without loading it up into some cluster or what have you. We query it straight where it sits, and we only then pay for the data that we process. So that's great, right? That revolutionizes a little bit how we do data analytics. Makes our life as developers, again, a lot easier very often, right? Again, serverless. Now, if you think about what that means, though, when I build code, now I know I have that data lake and Amazon S3, great, and I can tie machine learning to it and Hadoop clusters and run SQL queries on Athena and then run a BI tool against it and what have you. What does it mean for us as developers? Well, what if we start building integration straight into that data lake? Right? Push it straight from your app into the data lake. And if you need to do some transformation, think about how you can actually assist in the process of doing some of that data transformation. Don't blame it on your data scientist. He's there to find the data and look at it and find interesting values in it. We as developers, we can quickly shuffle data around. There are services like AWS Glue that also make it easy and managed for us to just write some Python code, transform the data. Key is we want to have it in a data lake that allows our data to be immutable. We don't touch it and we leave it there because we never know what we don't know. We don't want to go, in the future, say, okay, I want to do this kind of modeling. I want to go back to all the data from last year. And then you look at it and it's not raw data and somebody transformed it and all the important properties that would have made your machine learning model awesome are now gone. Right? So we want to have a place where we cost-effectively can store immutable data, our data lake. For us as developers, we should think about how can we effectively integrate and directly feed into that data lake from our application. Because in general, data analytics will become more and more serverless. And talking about that, that serverless thing, that AWS Lambda thing, can I use that for some cool data analytics? Yes, I can, because it turns out, if we talk about data analytics or data processing in general, very often we can run a lot of that processing in parallel. Take all these log files and do a certain mapping on it. That's parallel processing right there, if we can tap onto it. So we use something like Hadoop, right? Great. Or Spark allows for parallel processing. How about we make it serverless? There's a really cool open source project. I encourage you to have a look at it. It was initially written by a guy called Eric Jonas, great guy. Watch some of his YouTube talks, and he open sourced it. It's called Pyron. And Pyron allows you to run any existing Python code at massive scale in parallel in AWS Lambda. You can even run that code now from your laptop. Pyron will then call all the AWS Lambda function, does the transformation, use S3, by the way, as a place to also store the state, bring it back to your machine. And just to put that into perspective, because people tell me, Lambda is 1.5 gig memory max, what do I really get out of that? Parallel processing is huge. If you take a soft limit of 2,800 Lambda function, you concurrently process your data in parallel, you can reach up to 40 teraflops. You can process up to 80 gigabytes per second on Amazon S3. Why? Because Amazon S3 is designed for this parallel access. So that's really cool. And if you have a data scientist, you show him this tool and you say, you can run that from your laptop, magically goes into the cloud, does something, comes back, and you get the result. He's going to be like, yeah, cool, give me that cloud button right there, all right? So that's useful. That's really, really useful. But one thing that I encourage you to do, I keep saying developers, data scientists, and I keep drawing it like as if it's separate lines. It isn't. And moving forward, it will continue to merge. It will continue to converge. Glenn gave us a great overview this morning around what are some of the skills that we want to look for. Previously we had DevOps. Well, not previously, we still have. We continuously have. Right? But previously we had the scenario where we had an infrastructure guy and a developer, and they were always fighting with each other. And you say, okay, how about, we just own that together. We call it DevOps, and everything just runs smoother. You own what you build, you maintain it, awesome. The same thing now happens with machine learning. You don't just build your application and then say, the data scientist, he'll find the patterns. Because the way we're building our application, we will have certain data points, and if we collect them accurately, we can straight pass them to a machine learning model. So if we have an understanding of how machine learning works, we can overall make these things happen more quickly. And I truly believe that machine learning will become the new normal. There will be products that most of the products and most of the services you're building will use machine learning, and some of them even just exist because of machine learning. So it is a skill that we want to have, because if we have that skill, we understand how we create effective feedback loops. Machine learning models continuously learn, but they only continuously learn in a way that you provided feedback. If you don't provide feedback, you can keep training and training and training, and you train in a direction that is not correct anymore. If we as developer, we build the application, that's where we want to get the feedback loop from. Take a simple example. Take something like Amazon.com. Sometimes you go down to the bottom and you see people who bought this are also interested in that. All right? What's a simple feedback loop? Somebody clicked on it, bought it. My prediction was good. He didn't. Maybe it wasn't so good. Very simplified example here. But think about us as a developer, we can feedback that loop, we can create that feedback loop straight into our data lake from our application. Our data scientists will love us. So let's have a look and how we can continue to evolve that. And thinking about that, there's another interesting trend that we're seeing. If you think about traditional machine learning, it was very much about a data analytics pipeline. You store your data, then you start visualizing it. Somebody goes through it, looks at it. All right, there seems to be some patterns here. That looks good. Let's take that. Let's use some algorithm. And then you take that pattern and you develop a piece of code with an algorithm, with some of the commonly known classification or clustering algorithms, what have you, and you will start training a model, and then you will start predicting from it. So basically, you know the pattern, or you think you know the pattern, and that's how you now develop your machine learning model. Moving forward, that will change, primarily because of advancements in things like deep learning. Deep learning allows us to create a system and say, I don't know the pattern. I take the data, I run the deep learning model against it, give it tons and tons of input, and tell them how the output looks. And somewhere in between, it will find, there seems to be a pattern. And it will learn from those patterns. So now I don't need to know the pattern. I just learn from the data. And that is generally the concept of what artificial intelligence is built upon. Now, there are lots of definitions out there around artificial intelligence, and I'm not going to challenge any of them, but I want to share with you my vision of what I call an artificial intelligence at the current stage. I do think it is a system that performs the tasks that normally require human intelligence. But I'll add something to it here. I also want the ability to actually interact with a computer system to adapt to us humans and to act in a natural manner, rather than humans adapting to the system, right? Traditionally, we had to learn, and we go into a command line, we need to know exactly what we need to type in, we get the syntax wrong, we get an error, we need to correct it. We adapt to the system. Now, as a developer, we know how to get around that, right? We just write a script that calls another script that transforms something to do, and then call that. So we personalize it a little bit. But what I want is, I don't want to adapt to that computer system. It should listen to me. I should be able to talk to it. It should see me, personalize my content. That is where artificial intelligence starts. It understands us in a natural manner. Now, I mentioned deep learning. Let's put that into context. I'll give you an example here. This is a 3x3 Rubik's Cube. I had one. I never solved one. And I was highly frustrated because you go on YouTube and you see like the guy takes the Rubik's Cube, blindfolds himself, like 4 seconds later, he solved the Rubik's Cube, and you sit there for hours and you can't get it done, and you're like, come on, I'm stupid, all right? But then there's a reason why he can do that. There are patterns in there. But it's interesting, because I felt a little bit better when I realized, in 3x3 Rubik's Cube, what if I go ahead and look at all the possible unique combinations that I could have? You know what? On a 3x3, it's 43 quintillion possible unique combinations. All right? Make me feel a little bit better. A little. Now, what does that mean, though? Why can a guy on YouTube solve it so quickly? Because there are patterns. Patterns on how they're recurring on how to solve that Rubik's Cube. And by the way, there are videos out there that show you how it's done, and then you can learn it, and then you can do it quickly too. But what if we write an algorithm to solve something like this? We're developers. We probably all started off in some way in the computer science to kind of like, have a maze, solve the maze, find the exit to it. You're like, okay, I know recurring functions. I can build a backtracking algorithm, try every possible combination until I'm out. Could I do that to solve the Rubik's Cube? Of course. Will it be extremely inefficient? Of course. So we don't want to do that. Because there are patterns, we know them, we can solve it super quickly. So how are we going to go ahead with that? Well, we use deep learning. If we use deep learning, we can take a Rubik's Cube of a certain combination where we know how we solve it. Twist it, turn around here, etc. That's how you solve it. Now we create a learning function in between and say, input, output, learn from it. Brings me up to a certain accuracy. Now it can solve certain Rubik's Cubes, right? Like that exact possible combination. Now it can solve maybe a few others. Now, so I'm going to take another combination where I know how to solve it. Again, make the model learn from it. Then I'm going to go ahead and take, another 100 combinations where I know how to solve that Rubik's Cube. Have that learning function learn from the data that I just fed it. That brings up the accuracy of it, which will then allow me to take any possible unique Rubik's Cube combination, and it will predict with a certain accuracy, this is probably how you want to solve it. And if you think about artificial intelligence and deep learning, this is what it is about. Don't code the patterns. Learn from your data. And then I can have some fun, right? I can build a little machine, connect it to a small little device, load up a model, put some cameras on it, and solve every Rubik's Cube in 0.9 seconds. Take that, YouTube guy. There you go. So what does that leave us with? It leaves us with the point of we need to have data to train machine learning models. It leaves us with the point of we need to have data to create artificial intelligence. Sometimes just a little bit of data is sufficient to get a model with a certain accuracy that already works. But how do we bring that accuracy up? Right? We take the data, we train a model, positive, negative reinforcement, input, output, this is good, this is bad, this is good, this is bad. It's just like a human being. How do we learn how to walk? By falling, right? We crawl, we stand up, we fall. We crawl, we stand up, we lean a little bit further back, okay, we fall a split second later. Aha, all right, I need to lean back more. That's exactly how we train using deep learning, machine learning models. That went back, that's where it should go. Now, as we train that model, we now get a model from which we can start to infer. We can make predictions from that model. Now, if you build a machine learning model, you do this, you try it out, and you're like, good, I'm done, right? No, of course not. Your first model that you create is very often not accurate. So what you need is a feedback loop that goes back into your data lake from which you continue to train a model, infer from it, create a feedback loop, and continue, and continue, and continue. To increase the accuracy of your model. And this is that feedback loop that we as a developer want to create from our applications, from our APIs, from our microservices that we create. Put it back into the data lake. If we think about deep learning, there are lots of frameworks out there that can help us. TensorFlow, great framework. MXNet, Caffe, joint project, or Caffe 2, which is now jointly developed with great open source developers, Facebook and Amazon. Microsoft Cognitive Toolkit, CNTK, Torch, Keras. All of these frameworks run wonderfully on AWS. Now, we want to make it easy for you to actually run those frameworks on AWS. So we created the AWS Deep Learning AMI, which comes installed with all these frameworks. Now you're going to say, well, I don't need that. I know how to use wget and do some configure and make and done, right? But realistically, it also comes with all the drivers to access the GPUs, different libraries, and also, for example, the math kernel libraries of Intel MKL. Why is it important that I have the right installation here? Because even if we just zoom in, and Intel, our friends at Intel have been great at helping us to make deep learning more efficient. They came up with the math kernel library that significantly improves the performance when you do deep learning on a CPU. I wanted to share some numbers with you here. What we went ahead, we took a C4 instance and we said, okay, let's do some image classification. Label it, find the objects inside there, right? And we're going to use some, commonly known algorithms like AlexNet or GoogleNet or Inception, which are all common algorithms out there that use convolutional neural networks to actually classify images. And then we tried it with both, with and without that math kernel library. And what you see here is the amount of images processed per second. Yes, there is a bar down there, you just don't see it. Because it was multiple order of magnitudes in certain circumstances. Over 100 times improvement in performance on, for example, the Intel Skylake Xeon processors. So sometimes having the right libraries installed, like the math kernel library, can really improve your performance. So use that deep learning AMI. It makes your life a lot easier. So what can we do with that now? Well, computer vision, right? That's a cool thing. So what you see here, for example, is a video that is recorded on a car. It's not self-driving, it's actually a driver in here, but this model is used to try out how we can build self-driving cars. It's built by, or trained by a company called Too Simple. And what you see here is actually a car driving and using the model to classify objects and cars. You can't read Chinese, it actually tells you a little bit on what that car is, the brand and so on. And it will then allow you to also understand, is there a person there? Is there another car? Is there a bus? Is there a motorcycle, etc.? If you think about a model like this, right, that's cool. That allows us to use computer vision models to build autonomous vehicles. Now, it comes with a few challenges. You're going to tell me, yeah, cool. Love cloud, love AWS, allows me to train really well and fast and cheap and cost effective and what have you. Awesome, right? Now I'm gonna train and then I'm gonna run that model on my car, it's gonna drive around and then my internet disconnects and somebody's in front of me and I run into him. Why? Oh, no internet connection, couldn't infer the model, Didn't know there was a passenger. Of course not, right? So that model must run on the car itself. So if you think about how you want to use cloud computing in general when you build AI models, when you build machine learning models, think about training should probably always happen in a cloud computing environment. Why? Because it allows me to tap on massive amount of compute capacity, store massive amount of data points, millions of images, millions of video material to now train a model. NVIDIA also recently announced their Tesla V100 board. The single unit brings 120 teraflops. Pretty cool. We'll make that available for you to bring up and bring down at any point in time throughout the Amazon EC2 service. So great to train your model. But if you run the model, think about where you want to run it. You want to run it at the edge location. What is the edge location? The edge location could still be your AWS cloud environment. If I use a model to predict what you're going to buy on a website, well, that website lives in there, so leave it there. But if I use it for autonomous vehicles, I should push that model out to that car. Now, there are also some cool stuff that NVIDIA announced, like the Jetson TX2. Is about the size of a credit card, comes with a GPU, great for computer vision. You can take that small little device, install it in your drone, in your car, what have you, and now use computer vision to find something. Put it in a camera somewhere on the ceiling. Identify people with your machine learning model. How about that feedback loop, right? It's running now on that edge side there. We don't get the feedback loop. Well, that's what the services like Greengrass are for. AWS Greengrass would allow you to now push your model to that device, run it there, and then synchronize some of the feedback back into your cloud computing environment in your data lake. Keep training your machine learning model. Now, if you don't want to train machine learning models yourself, there are services that are available that can make it easier for you to get started with deep learning, because we train it and continuously train it for you. We heard about some of these services earlier. Poly, render lifelike speech, recognition, right? Identify objects in images, scenery, find faces, recognize people, perform image moderation, recognize celebrities. I'm still talking to the team to put me in as a celebrity. I haven't quite gotten there yet. Lex, build conversational or use natural language understanding, automatic speech recognition. And all of this is just like any other AWS service. It's a web service. It's why it's called Amazon Web Services. Everything is an API. Everything can be addressed programmatically from your piece of software. And similarly, now these services allow you to use a certain AI functionality, such as computer vision or natural language understanding, from your application by making an API call. So let's have some fun with that, shall we? Remember that Sphera robot? What if I want to take that Sphera robot and I say, I want to have certain objects, and I want to show an object into the webcam of my computer, and Sphero will then try to find that object that I place on stage here. I call it the banana finder. Why? Because I figured, how about I'll let it find bananas? All right, let's place my banana here. There you go. Now, the next thing that we need is obviously our Sphera robot. So let's have a quick look at that. Our Sphera robot, you remember this guy? We can connect to it. Now, the other thing that I need is a way of actually accessing my webcam and then sending information to Rekognition. So what would be a good place to put that? My web browser, all right? So what I'm going to do is I'm going to use JavaScript to actually tab onto my webcam here, create the tunnel of eternity. No, it doesn't quite work. There you go. And let's have a quick look at the source code here. Don't judge me. I'm a quick and ugly developer here. But what I basically did is I tap onto AWS Rekognition here. I take pictures from the webcam, and I then send it to Recognition. If I get from the labels back from Recognition, I will look for certain things that I want to know, and I will then inform AWS IoT about this is a banana, go search the banana. This is a can of Coke, go search the can of Coke. All right, let's try that out. So the first thing that I need to do is I need to reconnect my robot. There you go.
Hello.
Hello there. I'm going to calibrate this guy a little bit. Oops. So I place him here. There we go. It's very robot. Let's just get a camera on the robot itself now here. Now the next thing that I can do is I can say, start recognizing objects. Now my JavaScript is here going to take pictures from my webcam. It's going to send it to Recognition, and you see it will actually start right here. Gives me the labels back that Recognition came back with. So what I can do now is I could take a banana.
Banana.
There you go. Found the banana. I also have a can of Coke. I should try it with a can of Coke, but I have one issue. I have one here. Where could I get another can of Coke from? I know one guy that always likes to drink Coke. Glenn, do you like to drink Coca-Cola? Look at this guy. Look at this guy. It's like cans of Coke all the way right there. All right, come up. Bring me a Coke. Bring me a Coke. Now, I want this robot to find the Coke. How about we place it all the way down here? You know why I tap here?
My Coke,
you can ask me later. So, Glenn, do you think it's going to find the Coke?
You should have been a magician, Ollie.
Should I let it go for the Coca-Cola? Let's go for the Coca-Cola. There you go. There we go. And it went, let's try this one more time. So you can see it on the camera. Let's go back to the banana. Let's go back to the banana. There we go. Banana. Banana.
It's
banana,
full.
Banana.
Banana.
There we have it.
Banana. Ouch.
So Glenn, what do you think?
That's
you can
pretty.
find some Coke, have Sphero, find a banana, have some fun.
I think you're not busy enough, Ollie.
You see, I built demos, really try hard. You see all this stuff here, collisions, you can kick it, finds banana, still not happy.
It's a high bar.
I want you to stay here. I want you to now, since you know everything so well, how about you help me now understand what are some of the key points that we're going to go through here? I want to leave you with a few takeaways, and I want Glenn's take on that too, because he always knows everything better, doesn't he? No? All right, good.
Not at the end of the day.
Let's go back to the slides. This is a great demo, isn't it? Do you think so? The banana finder? Well, all joking aside, I think it's a perfect example to demonstrate a concept. Nobody's going to go out here and build a banana finder. But if you want the code, just drop me a note. What it all though means, and I really want to leave you with a few key messages here. As we look into the future trends, and I think Glenn would totally back me up here, the more we start integrating, the more we use connectivity, and the more open that we are around what we're building, we can create really great and successful products, right?
Yeah.
How can we use like Alexa voice services? Also, I can use my voice to now talk. Never built that model.
I think what's interesting, you showed the external integration, but it's just as important for internal. If you've got internal applications, that integration, connectivity, and openness is just as important.
Absolutely. And I want you to, as a developer, think about that. And, it always goes both ways, because open source is great. We take something, we build something. If you build something, let's use it. Let's make it open, right? Let's create APIs around it. Let's integrate around it. The other thing that we really saw here, even if it's just to find bananas on stage, we will continue to use machine learning models. We will continue to use AI models, and we will continue to create APIs or have great frameworks that will help us to build deep learning machine models. But what I encourage you to do is to think about what are some of these new interaction channels that we have, right? Can we use voice, right? Maybe we can use smart glasses, maybe we can identify gestures, maybe we can have a robot, right? We have the ability now to create a lot new cool applications if we tap onto the AI ML space for us as a developer. And I know you like to say it's never been a better time to build, but I like to say it's never been a better time to experiment around. So with that, thank you very much for your attention.
Awesome. Thank you, Ollie. I do think you do have the coolest job around. But just while you're up here, Ollie, look after emerging technologies, and so you get to see, what's happening in the industry across, these big mega trends. But I'm kind of curious, what are you most excited about as you look forward?
Everything, Glenn. Come on, bananas, of course.
You don't have bananas in Hong Kong?
They do, but this is a true Melbourne one, Whenever you fly into Australia, the guy's like, do you have any food on you? No. So don't bring anything in. Properly bought here in Melbourne, my friend. But what I'm really excited about are really some of the AI things we're seeing, the openness and integration, right? Don't you love that announcement there? Alexa voice services, Cortana, done back and forth. That's what helps us to build great stuff. I think as developers, we want to continue to ride that trend of openness and integrating the platforms. And what that means, although for you, is I think the AI, ML space will really start opening up. There are frameworks out there that make it really easy to get started. There are lots of APIs that can be. AWS is innovating on customers' behalf there. So tell us what you want, seriously, I mean it. Whenever you want something, we can maybe wrap an API around it. But what I'm also really excited about is that ability to say, I push that model out to the edge, I start connecting everything, bringing all that data back in, and really make use of it. That's exciting. You can really build cool stuff with it.
Absolutely, it's incredibly exciting. Ollie, thank you for sharing. If I look at just building what Ollie said, what excites me is actually what all of you build on the platform. It's amazing. When we generate these products and services internally to Amazon, we often have no idea how you're actually going to use it over time. We kind of have a good idea based on your feedback, but as you innovate and you discover new capabilities and new ways of integrating things and creating banana finders with Shiro, we never imagined that. And so what excites me is what you've learned today. Just hands up if you learned something today, by the way. Yeah. Awesome. That's the purpose of DevDay, is to give you the opportunity to spend time listening, learning, networking, sharing. There's actually research that shows that today, while you've been listening, if you've discovered something new and you want to try it, you want to apply it in the next 72 hours. Because if you apply the next 72 hours, it will stick in your brain. If you don't, it kind of wafts out the other side. To help you with that, I'll give you $50 credit if you give feedback. And so it's really important. We love getting feedback. We ran this event last year. We've made changes to it based on your direct feedback. And so if there's things you liked or things you think we can improve, or you've got different ideas you'd like to see, let us know. We'd love to hear it from you, and you get $50 credit, which you can go and build some amazing things with. There's lots of different ways to keep engaging. There's lots of education courses, there's certifications, there's lunch and learns, lots of things. So with that, there's going to be some drinks outside. On behalf of Amazon Web Services, I really thank you for spending an entire day with us learning. The team's going to be out there as well. Let's continue the conversation. I get last word, Ollie. There's never been a better time to build. Go build. Thank you, Melbourne. It's been awesome. Thank you.